I'm starting now. Bismillahirrahmanirrahim. Dance with the waves, move with the sea, let the rhythm of water set your soul free. Well, guys, how much we know about our ocean lives and resources? Scientists estimate that 91% of ocean species have yet to be classified. Actually, only 230,000 marine species are known, with over 2 million estimated to exist. Ocean waters around the world contain about 20 million tons of gold in them. Unfortunately, the concentration lies on the order of parts per trillion, making it extremely difficult to get. Based on today's spot price of gold, that amount of gold would be worth roughly more than $800 trillion. Ocean bottoms are rich with oil, gas, minerals, and so many other resources. So we have a huge range of marine species and marine resources. Well, Assalamu alaikum. I am MD Jahin Khandekar, founder of Octophin, a scientific community where ocean-loving students from different places and different platforms are trying to aware people about ocean. And today is the second day of our online live course, Exploring Ocean, Explore the Planet Earth. And we will know about marine lives and resources. Mr. Xavier Zylstra and Russell Stevens will take this lecture. They are representing the Two Oceans Aquarium Education Foundation, a newly formed non-governmental organization, actually non-profit organization. I'm very much pleased to introduce Xavier Zylstra. He is a senior educator with the Two Oceans Aquarium Education Foundation, born and bred in Cape Town. Xavier received his Bachelor of Science and higher diploma in education, concentrating on high school biology at several Cape Town schools, amongst others Rondebosch Boys High School, where he was subject head for over a decade. He joined the staff at the Two Oceans Aquarium in April 2009. He will lecture about the marine life. I'm also excited to introduce Mr. Russell Stevens, Head of Education, Two Oceans Aquarium. Russell has a rich teaching experience in both primary and high schools, as well as lecturing of didactics at teachers, colleges, and in the University of Cape Town education faculty. He currently serves on a range of education advisory boards, including National Board of Trustees for the South Africa's School Governing Body Foundation. His qualifications include various education diplomas and degrees in environmental and geographical science education. He is passionate about elevating environmental education, aquarium education, and marine education as a profession. Since 2000, he has been instrumental in sourcing, developing, and leading a team of aquariums teachers at the Two Oceans Aquarium who strive for excellence in marine education to serve a range of communities, including those subject to poverty. The Aquarium Education Center teaches 76,000 school children annually. Well, dear participants, if you have any question during the session about the lecture, you can ask us in the chat box. We'll try to answer, and if you are seeing the recorded file, you can comment in the comment section. Please enjoy the lecture. This is me at the end of my talk, and so I will now hand over to Mr. Xavier. Please, sir.
Thank you, Yahin. Good evening and salaam alaikum, ladies and gentlemen. Thank you for inviting me to join you this evening. I must say I do applaud you sitting in front of a computer screen to listen to lectures at 9 o'clock on a Friday night. I'm very impressed. It's not quite so late here in South Africa. The sun is just getting ready to set here, so I'm still sitting in the daylight. I've got quite a bit to get through, so I'm going to mute my video and share screen. And my subject for the evening is on marine mammals and creatures of the deep. Now, in my studies, I've learned a lot more and actually encountered and worked with marine mammals, so you will excuse me if I spend more time talking about them and a little bit less time about the creatures of the deep, which are truly fascinating. But I think for many of us, while they're very interesting, we are probably, if we're going to be marine biologists or oceanographers, we will spend more time with marine mammals and creatures on the surface than we are going to be spending with those creatures that are in the deep, deep, deep ocean. But they are fascinating, and I will share some with you. So let's start talking about mammals. And of course, mammals are land-living animals. They evolved on the land, probably from dinosaur roots to start with. And then after a major ecological disaster or several ecological disasters, the dinosaurs died out and the mammals and the birds took over as the leading vertebrates on land. But I think there would have been a lot of competition for food, and some of those mammals eventually spent more and more time on the shoreline and possibly then swimming out into the waves to go and get their food. And we have a fossil record that shows us quite clearly how four-legged mammals slowly but surely evolved to become marine mammals. I'm going to talk about those which are found in the South African oceans, but also in the Bay of Bengal, so that we can relate to the same creatures. So a quick introduction about what mammals are. And I've tried to share photographs that I've taken myself. So here in South Africa, we have several national parks where we've still got a very rich wildlife scenario. And here are some of the animals you would see if you went to one of our game reserves. Drinking at a water hole, so there's lots of variety because all mammals need to drink. I think we're all aware of the rhinoceroses, unfortunately animals that are severely endangered because people seem to want these rhino horns, and it's a pity that we can't take them off in such a way that we can use that as good as it can be and leave them alive. And of course the big cats of Africa and of Bangladesh and India with the Bengal tigers. This is a cheetah, and I was able to get very close to it because it was used to humans. This one I stayed in the vehicle to take the photograph because the chances are if you jump out and get too close to a lion, it's going to treat you as its next meal. Unlike sharks, which we all think are going to eat us, but are in fact animals that try to avoid humans and stick to their seafood diet that they're used to. And then, of course, the animals we really want to focus on. This is a photograph I took about a half a kilometer from where I'm sitting now. We're very fortunate that we have whales that don't go all the way up to the Bay of Bengal. They come to the South African coastline. They're called southern right whales. And although they spend most of their time in the Antarctic feeding, in our winter, which is now, they come to South African shorelines so that they can breed. And here you can see the mother and the little baby that she's just given birth to next to her over here. Okay, so what makes something a mammal? They're land-living animals normally, so they've got a waterproof skin, which means they don't dry out when they're standing in the sun. And that skin is covered with hair or fur. And there are some exceptions. They've normally got four legs or limbs, and those are normally under the body and of similar size. So if you think of a giraffe or a zebra or an ox, similar legs underneath the body so they can walk along on all four legs. They've got good eyesight and a sense of smell. And then very unique to mammals, I'm just going to get my pen quickly, see if I can find it over here. These things on the side of the head of the seal over here. We call them ears, but the scientific name is pinnae. And they are meant to act like radar dishes to pick up sound coming towards us and focus them into our eardrum. And they enable many mammals to hear really well, even at nighttime. So if they can't see what they're looking at, they use their ears and they can focus. And here is an example of a mammalian skull. This is a seal skull. And you can see that most mammals have got teeth that look different. So you've got these front teeth here, which are for biting off things, and you've got these sharp teeth here, which are for stabbing and holding on to their prey. And then the teeth at the back are for cutting meat and grinding up bones. And even in humans, we've got teeth that look slightly different from the front ones through to the back ones. And that's typical of most mammals, but not the marine mammals. When it comes to their breathing, there are some things that make them different from most other vertebrates. Firstly, they've got a layer of muscle between the chest cavity, where their lungs are, and the abdominal cavity, where all the other internal organs are. We call that a diaphragm, and it helps us to breathe better, to suck air into our lungs. The lungs themselves are filled with tiny, tiny little bubbles called alveoli, and those are surrounded by blood vessels, and that enables us to breathe really efficiently and to get oxygen into our lungs so that we can keep all the cells in our body alive. I do see a raised hand. I'm going to have a look quickly at the chat to see if that's a question. Or shall I wait for question time afterwards? Yahin?
Well, actually, we have a question answering session. So
okay.
At last we will go there.
All right. So if you do have questions, please write them down or put them in the chat, and then we can go and visit those questions during question time. So I'll keep going then. Right. And we say that mammals have got an endothermic ability. That means that our cells create heat to keep our bodies warm, even if we're in the snow like this Arctic fox over here. And you can see that it's got very thick fur, and that traps air, and that ensures that the heat being generated inside its body is used effectively. Okay, moving on. Most mammals are what we call viviparous. That means that they give birth to live young. We have the female mammals have got a uterus inside which the developing baby forms, and then when the baby is born, it is fed with milk. But there are some mammals, known as the monotremes, which do not give birth to live young. They lay eggs. And here is one example. It's called a spiny anteater. And of course, we all know the duck-billed platypus in Australia. In fact, both of them are Australian animals, and they lay eggs. So mammals don't need to give birth to live young. Some do lay eggs, but they all feed their babies with milk from mammary glands. These animals called marsupials, again, Australian animals, they give birth to babies that look almost like a little red bean with two arms attached to it. It's a tiny little thing, and it crawls into the pouch and attaches onto the nipple, and there is where it will actually grow. So they give birth to very primitive babies, which then develop inside their pouches. Okay. As I've mentioned already, there were several mammals at one stage that were competing for food on land and spent more and more time in the ocean looking for food, until the point where they became completely ocean going. So they had to take all of their land living characteristics, their lungs, which they breathe air with, and giving birth to live young, and 4 equal length limbs, and get it to work in the water. And they've done incredibly well. So despite the fact that they still have most of the mammalian characteristics, they have become excellent water living animals again. And if we look at the fossil record, we can see a lot of fossils indicating this move from land living animals to entirely marine animals again. And some of them spend most of their time on land, but just go and look for food in the ocean. And I think you have otters in Bangladesh as well. So they're partially aquatic, like the platypus and the otter. Others, like seals, only go onto land to sleep at night and to give birth to their babies. And then others, like dugongs and manatees and dolphins and whales, live entirely in the water and even give birth to their babies in the water. So in South Africa, we've got a large collection of a group of mammals called pinnipeds. Now, those you don't find on the Bangladesh coastline, but I thought they were worth mentioning because they certainly are very common in temperate waters. That's where the water is somewhere in the region of 10 to 15 degrees, and polar waters like the Antarctic and the Arctic, where the water can be just above 0. And there's 2 examples here. On the South African coastline, we have sea lions or fur seals, whereas in the much colder water, you've got true seals. Now, the difference between them is that sea lions, let me just get my pen again, still have tiny pinny ears sticking out on the side of their head. While true seals, you can see there are no pinny on their heads. And fur seals have back flippers that can point forward, so they can walk around a little bit on land, while true seals have got flippers that point backwards. So the fur seals spend more time on land than the true seals. And true seals will really only go onto land just to sleep on a beach or to give birth to their babies. Okay, so in South African waters, the fur seals form colonies in certain areas along our coastline, and there are literally thousands of them during the breeding season. With the really big males, you can just see one really big male over there, and here's another one over here. They will fight the other males so that they have the right to breed with all the females, and then they'll get themselves a harem of 10 or 20 females, and they'll mate with them, and they'll look after the babies along with the mothers. Here you can see off the seal colony, there are hundreds of those seals in the water. So every day they'll go into the water and get hold of their food, and then they will come back again to their breeding colony. This is a shot I was very lucky to get while I was snorkeling of seals in a seal colony. And you can see they like to play together in the water, and then they go out to the deep sea in order to get their food. And at this, not this time of year, but in our summer, they give birth to their babies. And here you can see a baby that's about a week or 2 old. And while the mother goes to get the food, the little babies all get together in like little kindergarten areas where one mother will look after them while the others go out and get their food. When the moms come back, each baby makes a noise that the mother can recognize so she can find her baby again. Okay, seals are not common off the Bangladesh coastline, but I'm told that the tropical version of seals is the dugong, and research that I read yesterday indicates that there are dugongs in tropical environments like the Bay of Bengal. I'm not sure if they're very common, but there certainly have been records of them being seen on beaches or dead individuals that wash up on the shore. You can see they don't have 2 flippers at the back. Their flippers developed into a tail fluke, almost like a whale's. But on the front side, they look quite a lot like seals again, very seal-like head, and they've got the typical front flippers of seals. Okay. And let's look at some of these truly ocean-going mammals. First group is known as, this group is known as the cetaceans, and it includes whales and dolphins. And I've chosen a set of both whales and dolphins that are common on the South African coastline as well as in the Bay of Bengal. So it's possible, if you are doing marine research or if you're interested in marine mammals, that you will see the examples I'm going to show you now. The first example is the humpback whale, and it's called that because it's got a tiny little fin, but it's on a hump on its back. And it's also characterized, or typically you're going to recognize it because it's got these very long, slightly bumpy front fins. We call them flukes, and that is typical of the humpback whale. So if you see a whale that is rolling on the surface and you've got these very, very large front fins, you know you're looking at a humpback whale. I'll explain what they eat in a moment. And then you've got the Broeder's whales. It's spelt brides, but it's pronounced brooder, after a Norwegian gentleman who named them. And it's quite similar to the humpback whale, except it doesn't have those very big front fins. There's another example. You can see it's got a far pointier nose. And then this section here with all of the folds in it, that is the bottom of its mouth, which it can expand into a huge bag so that it can feed. And in this case, you can see there are a whole lot of sardines in the background. That is going to be the food that they eat. And I'll explain in a moment the way in which they do that, because they've got no teeth in their mouth. The sperm whale does have teeth in its mouth. Now, they're not common on the South African shoreline, but I'm told they are far more common in the Bay of Bengal. They can dive very deep. Now, the average depth of the Bay of Bengal is about 2.5 kilometers, 2,500 meters. And they can probably dive to almost all the way down. So they can go to about 2,000 meters. They are known as toothed whales, and they will eat animals like giant squids. That's their favorite source of food. And the other group of cetaceans are dolphins. And dolphins that you would see in the Bay of Bengal as well as on the South African coastline where I took these photographs are the bottlenose dolphin, typically a very pointy nose, almost like the top of a bottle, and a very curved fin. That is what we recognize the bottlenose dolphin by. And there you can see them surfing on a wave. That is actually taken about 2 kilometers from where I live. Then we've got the common dolphin, also a very pointy nose, but you can see it's much darker on its back. And then there's a line down the side of the body, and its chest region is very light colored. So that classic dark top, light bottom is typical of the common dolphin. And then the humpback dolphin, not to be mixed up with the humpback whale, again has a very prominent hump on its back and a small little fin out the top. So it's very recognizable from that hump on its back. There you can see this guy's just jumped out of the water and he is taking a breath of air. So you can see his one nostril on top of his head, his blowhole. And that, of course, is a typical adaptation of dolphins and whales. Their nostrils have moved from the front of their head to the top of their head, so they don't need to get right out of the water in order to breathe. Only the top of the head needs to come out, and then their blowhole is what they breathe through. Okay, so their bodies are hydrodynamic. That means that they are very streamlined, like a sports car, so that they can move through the water with almost no effort at all. And their limbs are no longer legs. They've been modified to form the front flippers. And then this tail at the back is called a fluke. And the tail is in fact not evolved from their hind legs. It's just a collection of cartilage and other tough fibers. So when it dies, that entire thing will rot away. There are no bones in the tail fluke. There are, I'll show you a skeleton in a moment, which shows you that the leg bones have now just become tiny little bones stuck in the muscle somewhere in the tail region. So their rear limb bones are almost gone, and this tail fluke is taken over as what they use to propel themselves to move through the water. Here's a skeleton of a toothed whale, probably a sperm whale, and you can see there are finger bones on the front limbs. So although that is covered entirely with flesh, the finger bones, which show that they were possibly once land-living animals, are still clearly there, but they're completely removed from the tail. The only part of the original hind limbs that we see are those two tiny little bones there. So no back legs. This pointy tail here would have a large tail fluke attached to it. And there you can see the skull of a dolphin, and you can see they don't have teeth that look different like the other mammals. All of their teeth look the same for grabbing and holding onto fish, which they then probably swallow whole. And we refer to toothed whales and dolphins as odontoceti. The word to look at there is donto, which comes from the Latin for teeth. If you think of dentists or orthodontists, that's the word meaning something to do with teeth. And then you get the other kind of whales known as the mystaceti, not the odontoceti. So they missed out on teeth. They missed the teeth. And they've got something in their mouth hanging from their top jaw that looks almost like a very thick moustache. And what they'll do is they'll get water into their mouth with tiny fish and other small animals like shrimps and prawns. They close their mouth so that only these little plates, they're called baleen, are open, and then they push the water out through the baleen plates. And the water comes out, but the food remains stuck behind. So it's like a sieve that holds all of the food in their mouth while they get rid of the water, and then they swallow that food. And then they get another big mouthful of water, close their mouth so that just the baleen plates are there, squirt the water through to keep the fish and the other little animals inside, and then they swallow that, and all the water is gone. So they don't squirt the water out of their blowhole at the top. Their blowhole is their nostrils, and it's just for breathing air into their lungs. Okay, and here is a humpback whale taking a large mouthful of water, and you can see there are little sardines and things moving around here. So you can see how big that pouch gets. It's then going to close its mouth, and there is the baleen plate that it's going to squirt the water out of and keep the fish inside its mouth to swallow. Okay. I'm going to leave this for you to look at in the recording, but you can see the various parts that we've labeled on this animal to show you how well it's adapted to living in the ocean. Okay, as I've said, the nostrils are now on top of the head in the form of a blowhole. They can replace the air in their lungs very quickly when they come to the surface. When they dive, their lungs actually collapse, and the oxygen is kept in the red blood cells of their blood so that they can hold their breath for a very long time, relying on the oxygen that is just in their blood and on something called myoglobin, which is a chemical in their muscles that holds onto the oxygen as well. So they don't need the air in their lungs once they've taken a breath of air, because the air all moves into their blood and their muscles, and so they can hold their breath for up to an hour or two at a time. Many whales will migrate to tropical or subtropical oceans to have their babies during the tropical winter, and then during the polar summers, they will go either to the North Pole or the South Pole, which is where they do their actual feeding. So when you see whales on the Bay of Bengal coastline, you're really looking at mothers that have and fathers that have either come to have their babies or to mate so that they can have babies the following season. Right, and activity that we often see while they're also coming to have their babies is slapping their tails. That's called tail slapping. Diving out of the water like these two over here, and then crashing down again, which we call breaching. We're not sure why they do it, possibly because they're just having fun, or possibly to remove parasites that are on their skin. Okay, so that was a very brief overview of marine mammals, looking at dolphins and whales and seals. And now we're going to go to deep sea ecosystems. And this is really just a very quick overview. The Bay of Bengal won't count as a deep sea ecosystem because the deepest is about 4,600 meters, which is getting there, but the average is 2,600. The bay is quite filled up with sediment because of the Ganges and the Brahmaputra rivers, which have for millennia been pushing sediment out into the Bay of Bengal. So the delta that you see at the river mouth actually continues out into the bay, and it's slowly but surely filling the bay up. The deepest part nearby you is the Sunda Trench, which is off Sumatra, so that's down south, and it's a deep sea trench. It's the deepest part of the Indian Ocean, and it is 7,400 meters approximately, which counts as a deep ocean environment, and we're going to look at some of the animals we can expect to find there on the next slide. The deepest part of the ocean is just over 11,000 meters, so that's 11 kilometers deep, which means that if you took Mount Everest from its sea level all the way to its height and dropped it down into that trench, there would be still 2.5 kilometers of water above Mount Everest. So we think Mount Everest is very high, but the deepest trench in the ocean is deeper by another 2.5 kilometers. Imagine that. And of course, at that depth, I will explain at the moment, it's very cold. So what causes these submarine trenches? In this case, we are looking at the, I just need to make sure I've got it right here, at the Sunda Trench, which is over there. So here is the Bay of Bengal, and we're going down south to the Sunda Trench, and we see it's the joining between the Eurasian plate. I'm not sure if you know about plate tectonics, but the Earth's surface or crust is divided up into several plates called tectonic plates, and India and Bangladesh sit on the Eurasian plate. Actually, no, they're part of the Australia-Indian plate over there. And there's a join here between the Eurasian plate and the Australian-Indian plate. And the one is being pushed down underneath the other. And that's what causes the Sunda Trench. Let's look at that from the side quickly. So here's the Australian-Indian plate being pushed underneath the Eurasian plate, and so where it gets pushed under, there is a trench, and that runs along that line over there. The point at which the one plate goes underneath the other plate causes volcanic action, so you get a line of volcanoes forming to the one side of the trench, and that would be the Indonesian islands, Sumatra, Java, and so on. Okay, so that's what forms the Sunda Trench, and it counts as a deep ocean environment. So some deep sea statistics. The pressure is 1,000 times or more what we would experience on the surface. So if you sent down something like a tennis ball to that depth, it would collapse down to something the size of a pea. the temperature is just above freezing. It's pitch dark. It is totally, totally dark. No sunlight penetrates down there. And food sinks down from above. So the plankton and animals that live on the surface, when they die, sink down. Food can also be by eating other animals that live in the water column, or by a process known not as photosynthesis, but chemosynthesis, where bacteria down on the ocean floor use material that's coming up from the volcanic action and turn that into energy, chemosynthesis. And so, although you don't get them in the Sunda Trench, many of these deep ocean environments have gases that are escaping from the sea floor, and they form what we call hydrothermal vents. So around them, the water is above 100 degrees centigrade, but just a little bit away, it's 3 degrees centigrade. And this smoke and material that's coming out of the ground is used by bacteria to manufacture food. And there are quite a few animals that live down there that feed on that. Starting with the giant tube worm. These worms here live in special tubes. They're up to 2 meters long, and they've got this broad fan of very red material that they stick out of the tubes. That is their gills, and they use it to extract oxygen from the water. But they have no mouth and they do not feed. When they're young, they take bacteria into their bodies, and from then on, they take chemicals out of the water and into their blood, and the bacteria use that to manufacture food. So the bacteria have a place to live inside the bodies of these worms, and they produce food for themselves as well as for the tube worms. You can see next to them, these funny furry things are sea anemones, just like sea anemones that you would see in rock pools. Even at that depth, they are sea anemones, and they'll be feeding on material that is drifting down from the surface that they can filter out of the water. Anglerfish live in the water column, so they're not down at the bottom. They're maybe 100 meters or so above the bottom, and they've got a little rod on their forehead and a thing called a photophore. It's like a little light bulb, and they use something known as bioluminescence. It's a biological process to produce light, and they can switch this little photophore on and off and wave it around in front of their face over here. So it comes down and they wave it around over here. And small animals and shrimps and other creatures, maybe little fish, are attracted to this little moving light. And they, like moths coming to a light, they come and have a look. And the next thing they know, this huge mouth with these very sharp teeth grabs them and they become lunch. So the anglerfish is fishing using a little glowing lure. I wouldn't like to meet one of those on a dark night. Sea cucumbers. I know you would get sea cucumbers in rock pools, and these guys don't look very different, and they crawl along the sea floor using these little legs, almost like a caterpillar, and around their mouth they've got a thing that looks like a feather duster, and they use that to scoop up mud from the sea floor, and in that mud is a lot of food which they then digest through their bodies and egest out the back. So they're almost like earthworms living down 11 kilometers below the sea surface. There are jellyfish down at that depth, hovering about 300 meters above the ocean floor, and they are going to be feeding on small animals that live in the water column with them. Most of them have the ability also to produce light, so that the little animals are attracted to them and then caught up in these stinging tentacles, just like jellies that live on the sea surface. And then the vampire squid looks very much like an octopus. In fact, at one stage they thought it was an octopus. It swims using these peculiar things that look like ears on their heads, and then they use the spread out almost like a net between their arms to attract, because they can also switch on little lights which attract animals to them, and then they get caught up in the tentacles, and they've got a massive beak in their mouth with which they can bite and crush and swallow their prey. So they're going to be eating small shrimps and other animals that are moving around in the dark at that depth. And that is a whirlwind tour of the deep ocean. Thank you for joining me on this voyage of discovery. And as Yahin said right in the beginning, there are about 90% of animals in the ocean that we haven't even discovered yet, because they're living not necessarily right in the deep submarine trenches, but they're living in the deep ocean where we still don't have the ability to explore very easily. So we have to make use of very high-tech submarines, or even what we call remotely operated vehicles, ROVs, that we send down from a ship, and it does videoing and collecting using little robotic arms. Ladies and gentlemen, thank you for your time with me. I hope you've enjoyed that, and I will be happy to answer questions when we get to the end. And now I'm going to hand back to Yahin and to Russell. Thank you. Yep, stop share, there we go.
Thank you, Xavier, for that extremely interesting presentation. I love listening to Xavier talk about all that he does in the different lessons that we have. Salam alaikum, and without further ado and all other protocols observed, let's have a look at the harvesting of marine resources. My presentation, as Professor Udden last night, is going to potentially offer a huge amount of information. And because I'm being respectful of the fact that in our audience we have people who do have experience of the ocean, harvesting of marine resources, I'm just going to give you a brief introduction to all that I'm going to refer to, trusting that if you're interested in a particular topic, that you will go and Google it after me, or you can send an email and we can converse further about that. Just need to get used to, no, let's try that again. And get to move on to the next. There we are. So my presentation is entitled actually Establishing the Balance, Marine Resources, the Positive and the Negative. Human harvesting of the ocean has occurred for thousands of years. In fact, in the fossil, not in the fossil record, but in the, yes, in the fossil records with early humanoids, there has been evidence of fishing equipment of sorts. And humans for thousands of years have harvested plants and animals. As we have increased our capacity as humans, particularly with the onset of the Industrial Revolution, ocean resources have become very much more resources that are accessible. And we need to understand what resources can be found, and then secondly, how do we extract these resources sustainably? So to give a synopsis, marine resources have got physical resources, energy resources, biological resources, and then there are non-extractive resources. So the physical resources will be on or in the seabed, deposits, precipitated deposits, or accumulated deposits. The energy resources really are from, we saw a bit about the ocean vents, in the ocean trenches. There are some vents in certain parts of the world. And that heat is something which can be used to generate electricity. We'll also have a look at how electricity can be generated just off the shore of Bangladesh, in fact, in tropical waters, because of the differential between the warm water at the surface and the cold water below. The motion of the sea and motion of the air is certainly something that also can add to the energy resources. Then there's the biological resources, the animals and plants, the algae, invertebrates and vertebrates. And then we also have non-extractive resources. The ocean, as Dr. Uden mentioned last night, Professor Uden mentioned last night, is that it is the largest transportation medium, but also we have an opportunity for recreation. It's seen as a resource for waste disposal, and we also have it as a resource for tourism and other non-consumptive elements. So our physical resources. The most known is probably the drilling for fossil fuels, crude and oil and gas. And I believe that in 1906, there was the initial extraction of gas in the Bangladesh area, although the potential of extracting oil and gas in the Bay of Bengal has not been exploited as much. But 30% of all the oil that we use as humans is actually pumped from deposits off continental shelves around the planet. And what is interesting is that this is a very limited resource. And we all fear that when this oil is, the finite supply of oil is extracted fully, that Antarctica will be the next continent where oil might be considered to be extracted, and hopefully that we'll have alternative methods of energy at that stage. But minerals, there's a huge volume of minerals such as manganese, phosphates. We know the table salt that we use comes from the ocean, but the largest deposit that is used from the ocean is actually sands and gravels. By far, this is the element that, not element, the resource that is used. But deep sea, we have minerals such as copper, iron, manganese, nickel, and cobalt. So if you go off the Hawaiian Islands, you will see deposits like this. These are nuggets of manganese. And you can see it's like a huge bed that you will find on the seafloor. The seafloor is not totally flat. It has many features, just like on land. There are canyons, there are mountains, there are like hilltops and guyouts, a whole bunch of different landforms that you would find. It's not always flat, but in some flat parts, what happens is through the mud over millions of years, the different minerals, such as manganese, has been precipitated up to the surface. This is a deep sea marine crawler. You can see how huge it is and what is proposed to be used, and is in fact being used for the mining of the seabed. Our key is, and you'll see in every single one of the things that I present, you will see the positive and the negative. Unfortunately, a seabed like that will not miss out thermal vents such as this, nor animals such as these. So there is the dilemma that we have. How do we manage the extraction of marine resources and balance that with a protection of habitats that are so much needed? If a deep sea crawler was to go through areas where fish would be spawning, and it would be areas where the fish develop as juveniles, we will in fact destroy a whole fishery, and we'll find we'll be full of we'll be managing to extract lots of phosphates or manganese or copper, but we will then have no fishery left. So what I challenge you as scientists and as professionals of marine science is to consider how we would develop spatial planning models in which we can protect and in which we can extract in a sustainable way. Here is an example of oil and gas rig off Nigeria. And we know very well that that's not always a positive thing, because here is an example of the deep sea horizon where there was a huge oil slick damaging ecosystems, and we then actually were responsible as humans as we consume oil. So we must be aware of the downside for the consumption of the oil. So as marine scientists, we need to balance the way in which we consider the extraction of oil and gas with the potential damage that that can cause. Then we have biological resources: fish, trawling and fishing, shellfish and seaweeds. Seafood is the most commonly used, not by mass, because I've mentioned the gravels are the largest mass, but it's the most common resource that is consumed. Approximately 9 billion tons of seafood is extracted from the ocean each year. Unfortunately, 30% of fish stocks have collapsed, and all fish stocks we're looking at seeing a collapse of all fish stocks by 2050, unless we use preventative measures, and you and I as marine scientists look at a balanced way of extraction, because we have a human population needing food to feed 7 billion people. So here's an example of sea plant, seaweed extraction and harvesting in Bali. And we also have an example of an industrialized approach, and this is in Scotland, where there is this harvester which is mechanized. It's like a boat going through, picking up the sargassum or whichever seaweed is found there. We also have a lot of farms. Mariculture is a very critical element of the future moving forward, and I haven't dwelt on that. That's a whole subject in itself, but I did want to show you a Namibian oyster farm which I saw last year, and this is a very, very sustainable breeding at a mariculture facility of oysters. And here we see further mollusk harvesting, people putting down different places where the mollusks, mussels can grow. And then we have trawlers. Here's an example of a trawler where somebody's just cleaning out at the back. And this is where we have had huge consumption of seafood. This is used to be the Irish dawn, now called the Atlantic dawn. It is the largest fishing vessel. This vessel has a net twice the size, it has 2 nets in fact, twice the size of the London Millennium Dome. You can imagine that soccer stadium, a huge soccer stadium, and twice the size of that. That's the size of the net. And it is able to pull out the one net and then release the next net. So it's actually shipping with 2 nets at once so that it can pull in from the ocean. It was built by the European Union. And the irony about that is that, and we as developing countries need to be very conscious of this, in that the European Union built this vessel using European Union taxpayers' money, and yet there wasn't a single piece of the ocean off European waters where it could have fished. So it had to go and fish elsewhere. It's a factory fish. So you'll see there's a helicopter deck on top, and basically the only thing it needs to come in to do is to land is to get fuel. Otherwise it can just go back and forwards on the ocean. The personnel as well as the food supplies for the personnel can be replaced while it's busy. There are undesirable outcomes of fishing because at times there's an inefficient use of a catch. For example, shark finning, where the shark is caught and only the fin is taken. The rest of the shark is thrown back into the ocean. Bycatch, there is a huge amount of wasted bycatch. Those are untargeted fish that are just thrown back into the ocean. And mostly because they've been brought up from the bottom, their swim bladders have actually expanded, and it's that process of barotrauma causes the animal to die. And then there's habitat destruction, which occurs when trawling occurs on the bottom. Desalination is the removal of salt water, and we, particularly in drier areas, not in Bangladesh, you sometimes feel you've got too much water, I'm sure, particularly when flooding occurs. And when that does happen, I send an email to Professor Udin to find out whether he's all right and whether he and his family are safe. But there is a downside also to desalination, is that there is a leaching of the minerals from even the human body. So you can't have pure desalinized water. And even if you had metal pipes, copper pipes, it can leach out the copper from those pipes, so damage the pipes from inside. But the big thing is that it is a very high energy consumer, and hence it's not really ideal in this time when energy is at a premium, particularly in developing countries where we have electricity shortages. So there's an example of, last year we were at the Namibian desalination plant. That desalination plant is able to provide water for half of Namibia, and they've got a license to provide water for the other half and pipe it to Windhoek and the rest of the country. So it's a huge plant which is able to provide water for human consumption. And then we have non-extractive consumption resources, and this is really what is preferable. I see there's a whole lot of lines coming onto my screen. I wonder how that is happening there, but I'm just going to ignore them. The basic principles of energy generation is that at a higher level, maybe you see the arrow there, there is a head of water, in other words, a pressurized amount of water. This could be maybe up in the Himalayas, and then it goes down using gravity feeding and goes through a propeller over here, and that turns a generator, and then that generator produces electricity through a transformer onto the grid. People have been very creative. Here are two devices that are energy generation devices from waves. Another interesting one from waves, where it actually produces a wind flow, an airflow, which goes through like an air turbine there. The reason for this is if you put any kind of device in the salt water, it will tend to corrode very quickly and rust. So that's why there have been a whole range of wave energy generators. And then we have the wind turbines that are also found. These, particularly in areas where there's not much space on the land and there is a very strong wind, these turbines can generate electricity and the cables take to land. Something that is an area of technology that's not been very successful has been ocean current electricity generation. It has been tried in various parts of the world, such as Canada, in like the Bay of Fundy, but the ocean currents are so strong that they literally rip the mechanisms out of the seabed. And so this is a technology that is needing a lot of development at this stage. I mentioned the heat differential. If you can imagine at the bottom of this device over here, there is a temperature of 4 to 5 degrees Celsius. And at the surface, you will have a tropical area, tropical waters of 25 degrees. What happens is that this heat differential can be, or is enough to generate electricity. And when I share this, you'll find that on slide share, and there is a whole PowerPoint that explains that, and you can find the detail of that when you look at this afterwards. So there's the general principle. You've got this floating device here. Down below, you've got colder water at 4 degrees, and then at the top 25, 27 degrees, and that is also explained by the OTEC slide share. Then ocean transport. Ocean transport, recently there have been enormous vessels built for ocean cruises. This is the MSC, one of them. Absolutely enormous, can take 3,000 to 5,000 people at one point in time. Luxury hotels, and that is what's used in the ocean by ocean liners. Ones that are this top heavy tend not to be in the open ocean as much, and they tend to go around the fjords of Norway and in the Baltic Sea. And then container ships. Our largest amount of transporting of goods, whether it's cell phones or televisions from various parts of the world to another, anything we normally can buy online or we purchase internationally comes via a container. But there's a downside to this fishing, both types of fishing. Last month, there was one of the vessels, it is alleged by the BBC that the people had a party on board and it ran aground in East Africa. And so we have a downside and oil slicks that relate to the vessels on the sea. So, ladies and gentlemen, this is where we need to use our marine sciences experience to balance the advantages with the disadvantages. And then there's recreation. This is a huge opportunity for us, particularly in developing countries. And Professor Uden pointed out to me the Cox's Bazar beach. I saw somebody in the chat saying they came from Cox's Bazar, longest beach, huge opportunities that one has. And beyond that, I know there's an aquarium that he has been working with, a very small aquarium, but certainly something that's got potential for marine education, earning an income where it's non-consumptive, and that's the advantage of recreation with the ocean. Whether it's surfing or paddle boarding, something that I think could happen around Cox's Bazar. And also that the waterfall behind Cox's Bazar, it probably is kilometers away, but as I've Googled it, I've seen that there's a beautiful freshwater waterfall and streams in a national park there. And then a public aquarium, such as the Two Oceans Aquarium, is an ideal opportunity to blend what we see in the ocean with visitors and tourists. Somebody asked in the chat when Xavier was presenting, what is the economic value of mammals? And so I quickly put this slide in while he was presenting. And this is an example in Cape Town, off Cape Town, of boat-based whale watching. And certainly this is an industry that for South Africa has brought in a huge amount of income. And it's an opportunity where instead of having a consumptive approach to the ocean marine life, we can use it as an opportunity to have tourists visiting our shores and being involved in enjoying the beauty of marine life. This is one of the world famous free divers, Hanley Prinsloo, watching a bird from below. And another example of Cape Town is the free diving with seals that Xavier spoke about. Kayaking and surf skiing. But then there's a downside, and as Bali is a tourist destination, tourists also bring lots of litter, or if there's not correct management by us as marine scientists about how do we deal with the litter and the waste brought into our tourist areas, we won't be able to sustain the tourist levels because of the downside to tourism, because of levels of consumption. So that requires lots of marine education, environmental education, and awareness on the part of the tourists. An example which we all need to, as marine scientists, take up, and oceanographers, is this is the Namibian research vessel, the white research vessel in the background there. You'll see the Ocean Warrior is the Greenpeace vessel, which is a vessel that's played an important role in protecting ocean environments, and you can Google the work that has been done there. So it's very important for us to have research vessels, because as marine scientists, if we go along and say we want to protect a particular area, such as an area around Cox's Bazar, and we'll say that's going to be a marine protected area, we need to defend the science that we use that determines that that is an ideal place for the marine protected area to be positioned. Each country has got an exclusive economic zone, and that is just off its coastline where there's a legal jurisdiction over that 200-kilometer area. But beyond that is the high seas, and it's what happens in the high seas which we as developing countries need to be conscious of. I'm not going to go into too much detail with that because I'm probably going to run out of time, but the important consideration is what we need to consider as being the tragedy of the commons. And this occurs when, in terms of the high seas, when there's no area that belongs to any particular country, where humans exploit a shared resource in a way where the demand exceeds the supply. And in this sense, the resource becomes unavailable because some people, or even more countries, and those have exploited areas beyond their economic zone. And so that is something that we as marine scientists need to balance up and work out what the fine balance might be. Because we do not inherit the world from our ancestors. We borrow the world and its resources, marine resources, from our children. And on our watch, we need to be able to work out what is the balance that we can put in place between consumption and planet Earth. So if we have a look at the Bay of Bengal and what we are entrusted and we need to care for, and we take care of our planet, which I have just below that, it's important that on our watch, how will our grandchildren thank us? And ultimately, the responsibility is ours, not because we just are humans existing on the planet, but because we are humans that have a particular interest in marine life, oceans, the blue economy, and further development of the blue economy. So thank you. That's all from me. And I hand back to you, and I'm sure we can field some questions at this point.
Well, I'm stopping the screen sharing.
Thank you.
And thank you, Mr. Russell Stevens, and thanks to Mr. Xavier Zylstra. Now I am asking Orna Sanjila to start the question answering session. Orna Sanjila from Octophin, I'm asking you to start the question answering session.
Okay, thank you, Mr. Xavier. Sorry, I'm having confusion.
My pleasure.
Okay, now this is Sanjila Sharmin Orna from Octophin Scientific Community, and welcome everyone to the question assessment session. So the first question is from Alfie Islam, who wants to know what is heterodontic teeth. I'm passing it over to Mr. Xavier as you covered this part of the presentation.
Okay, I did see the comment was answered. Heterodontic teeth means that in most mammals, there are different kinds of teeth in the mouth to perform different functions. So our incisors in front are for biting off things, and canines for predators is for catching and stabbing their prey, and then the molars at the back are for chewing and for grinding up bones. So it's almost like having a Swiss Army knife in your mouth. You've got lots of different tools to manage the food.
Okay, thank you. So the next question is from Khondokar Nusa Tabasum, who asked, is cetaceans a kind of whales?
Indeed they are. As I eventually did explain, the cetaceans include the whales and the dolphins as a group.
Okay.
And that's why you would have heard that the CT part of cetacean comes in the names of the toothed whales and dolphins, the Odontoceti, and the baleen whales are the Mystaceti, so cetaceans without teeth. Next up.
Okay, moving forward, Shukumar Chandra thus asked, what's the cause of jumping out of water of these mammals like dolphin and humpback whales?
I think they enjoy it. And very often there is no reason for why they're doing that, apart from that they just really are having fun. But then I did mention in some of the whales, I think if they've got parasites on their skin, that jumping out of the water might loosen the parasites.
Thank you. Next, Mr. Aswad Simon asked, how do deep sea fish and other creatures survive in the pressure of the ocean?
Okay, when it comes to ocean pressure, the big problem is if there's an airspace in the body of the animal. So when we go diving, for instance, we've got air in our ears and in the bones of our face and in our lungs. And the increased pressure causes that air to change its shape. And that's where the damage comes in. The animals that live in the deep ocean they've just got cells with fluid inside. And that fluid is not really compressible. So long as there's no air spaces in their body, they're not really affected by the pressure.
Thank you. Moving forward, Sarah Coppinger asked, do marine biologists know why those remaining back leg bones of whales have not completely devolved? Why are those small bones left?
Wow. It's possible that the evolutionary process is not complete. So it is likely that in a few millennia more, those bones simply won't be there anymore. We call them vestigial bones, in the same way that some animals have got vestigial organs. So we've got an appendix attached onto our intestine that serves no purpose and sometimes gets inflamed and makes us very ill. It's the same thing. It serves no purpose, but it's a historical thing that we used to maybe use once upon a time. Same for the whales. They just haven't lost those bones completely yet.
Thank you. I think the question I got his answer clearly. So moving forward, MB Sabir Hassan asked, why do hydrothermal vents form?
Okay, they normally form in the deep ocean trenches where two of the ocean plates are moving apart from each other. So the ground is actually opening up at that point and lava is pushing up from underneath to fill the gap. And so in places that breaks through to the surface and you get all of these gases being released at the hydrothermal vents.
Next, Sajid NMK asked why nutrient shifts happen for deep ocean. He saw a giant tube worm get to nutrient shifts in the hydrothermal. Why did this happen?
Okay, because it's a very active area of the Earth's crust. There are constantly earthquakes and volcanic action taking place, and very often that changes what's happening underneath the vent and it stops producing the gases. And as soon as those gases stop and the water temperature drops, those tube worms die because they don't have the chemicals they need and the water gets too cold for them.
The question is from Mutahar Hossain. He asked, did Megalodon shark really exist at the ancient time, or it's only a fiction?
Based on the size of the fossil teeth that have been found, they're fairly sure that a large shark like the Megalodon did exist, but it would have been at the time when there were lots of very large animals in the ocean for it to feed on. So yes, I do believe it existed, but I do not think it has a food resource now. So we don't think they exist anymore.
Okay. Finally, Lucas Vega asked, is there any evidence that this beautiful deep marine biodiverse has been affected by plastic or human pollution?
I read some research yesterday that indicated that there are filter feeding animals and bacteria in the ocean depths that physically feed on the plastic. So there is no question that when plastic breaks down, which it does, all plastic, it doesn't go away, it just breaks into smaller and smaller and smaller bits. And it eventually gets to like little grains of sand that start to sink into the ocean depths. And every part of the ocean food chain is getting that plastic into its body.
Okay. So that's all from your segment of the presentation, Mr. Xavier Zylstra. And I must mention, photographies are so amazing. Thank you.
Thank you. Thank you very much. It's been lovely presenting for all of you.
Thank you. Now I'm heading over to Mr. Russell Stevens.
Hello, yes.
So, Mr. Stevens, the first question for you is from Zerin Sultana, who asked, we have acquired the maritime boundary of almost equal to our country's area from India to Myanmar. What things could be done to properly utilize this huge area?
Well, one of the very important elements that has become a very strong unified effort has been the International Union, IUCN, of Conservation of Nature, where there are ocean platforms for discussing ocean development of ocean extraction on a regional level. And what I believe is very, very important to happen is that the regional governments get together just as much as regional governments are working to get together in other parts of the world to understand how best to manage the extraction of resources in between the different countries, be it India, Bangladesh, and Myanmar. The important part possibly will be areas where there is, which are critical for the breeding of fish, that those be set aside as marine protected areas, that there also are international agreements with foreign vessels about the territorial waters and how the resources that are found in the area are going to be utilized, and then to look at, for example, if there was to be oil extraction in the Bay of Bengal, there needs to be a very clear idea as to how that the equipment used could manage the monsoons. And if you don't have that managing the extreme weather events, then it's not going to be a sustainable approach to extraction and to use the resources. Thank you.
Thank you very much. The next question is from Julia Veranita, who asked, how to balance among ecosystem, economic, and also people behavior?
Yeah, there are different ways. I was in a webinar yesterday where there was a discussion about how to balance the economic use of various marine and ocean resources. How do we balance poverty with the need to make a profit out of various resources? And the first consideration is to have a consultative approach. So those communities that consider themselves to be stakeholders in the management of an area are consulted in order to best understand what traditionally they have understood to be their rights to harvest and consume, and then to use the input from capital intensive extraction companies, for example, fishing companies that are listed on the stock exchange and are looking for profit out of the resource, and then balancing that with subsistence users of the ocean, and to sit down at a table to discuss these rights and the perceived rights. What is very important is that most fishermen who go out, or fishermen going out onto the ocean now, have got cell phones with a GPS. They have fish finding devices. So the mechanism of what is available now is very, very much more efficient than has been in the past. Just having a fellow fisher phoning on their cell phone to say, you must come to this part and this is where the fish are biting better, is going to be a more efficient effort. And scientists will know that you measure the amount of the efficiency of harvesting of seafood by catch per unit effort. And so we need to consider the efficiencies of technology, and it needs to be we need to make sure that it isn't just a top-down approach, that there isn't just a natural science-based approach, that we include social scientists who understand communities and cultures and traditions, and we blend together to make the balance occur. That's a short answer of a very long webinar that I attended yesterday, in fact.
Thank you, Mr. Stevens. So the next question is from Godwin, who asked, he thinks crabs are bioturbulence that can mix the minerals in shorebed. Is it true?
Sorry, can you repeat that? I didn't hear it fully.
Yeah, sure. Godwin said he thinks crabs are bioturbulence that can mix the minerals in shorebed. Is that true?
Oh, crabs can mix the minerals in shorebeds?
Yeah.
Crabs. I'm not a biologist. I don't know whether Xavier would like to answer that. I have not heard of that, but I'm learning every day, so I can't answer that. Xavier, what do you think?
You got me on that one. Sorry.
Yeah.
I don't know.
So
crabs are bioturbulence that can mix the minerals in shorebed. Is it true or not?
Not that I've heard of. So I'll have to research that and find out, and I can email it to the Octophin staff.
Well, no problem.
Yeah.
We will answer these questions in our comment section of our recorded file, and we'll provide these answers with our soft copy of these lectures. So don't worry, please.
Thank you.
Yeah. We all have something every day. Okay. The final question is from Ashikur Rahman, who asked, can't we use an autonomous underwater vehicle to extract minerals without destroying the habitat?
There is a need for greater research for the more sensitive extraction of the seabed, from the seabed. And one of the devices that can be used is an underwater camera that can observe what is seen ahead of the crawler that goes along the ocean bed. When I'm talking about the ocean bed, what I was reading yesterday is that, for example, off the coast of Namibia, there are huge deposits of phosphate. This is because there's a lot of upwelling that has occurred over millions of years. And if they were to extract these phosphates, they will actually extract 6 meters of sediment. That is an enormous amount of sediment that is going to be extracted. And then it goes up to a ship, and then plumes of sediment will then be in the water column after that. And if there are sensitive areas, with adequate research, they will find a way in which they can remotely steer these vehicles around sensitive areas. The one example is that there is a marine protected area that has been declared off the coast of South Africa. Many thousands of years ago, there was a forest there, and there are now petrified trees. Our national tree is called the yellowwood, and they're actually well-preserved yellowwoods that are on the seabed, that if one of those devices was to come through, it would literally destroy that forever. And because of exploratory research beforehand, scientists have then understood that that is an area that needs to be protected, and so no extraction will happen within that deep water marine protected area. And that is, in my view, that's a critical consideration for when we look at how to sensitively balance human use of the ocean and consider the ocean as having its equitable rights for protection at the same time. And it's an area where, as with the last question, you know, it's important that we do only answer the questions that marine scientists know. There's a lot that we don't know. And the more we tell people about the fact that there's a lot we don't know, the more they will respect how much further research has to happen in order to best understand and best utilize the resources in the ocean that we have. So thank you very much. It's been a privilege for me to be able to share with you today.
Thank you. And the concluding question is from me. Will we be lucky enough to have both of you by Octophin side in near future as well? So, Mr. Stevens and Mr. Zylstra, my question is to both of you.
Well, Professor Uden and I have wanted to plan for a conference or some opportunity for us to come and visit the University of Chittagong, and we haven't yet got that in place, but perhaps after COVID we will be able to come and visit. But visiting aside, what is really important is COVID has given us an enormous opportunity. This is the second time I am sharing via a video link with people in Bangladesh. The first was in World Ocean Day, where I gave a presentation. And with low carbon consumption, without flying, and with the opportunity to have these video link-ups with your marine sciences community is an opportunity for us to join hands from our laptops and to be able to build relationships, to build an understanding, collectively find ways of jointly establishing the future solutions of the oceans for our children and our children's children.
Yes, thank you, Mr. Russell Stevens. Thanks to Mr. Xavier Zylstra that you have given us a very, very informative lecture. We Octophin thinks that participants may enjoy this, and actually we are thanking specially gratitude to the Two Oceans Aquarium Education Foundation. Thanks to all our participants, and I am also adding that we'll be very glad to have Mr. Russell in our country, in our University of Chittagong. We are now going to end this session. Well, thank you all. Stay with us. Stay safe. Stay sound.
Thank you.
Thank you. Have a good evening and a good weekend.
Well, actually, goodbye.
Cheerio.